In this video, we'll delve into the concept of friction in Unity, exploring how it can be effectively utilized and the underlying physics principles. We'll explain the differences between static and dynamic friction and demonstrate how two physics materials interact in Unity. Static friction is, as it sounds, the friction created between two surfaces when they are not moving. For an object to move, it has to overcome this type of friction, but once it is moving, dynamic friction kicks in. In real life, static friction is greater than dynamic friction, and that is why ABS, anti-lock braking system, makes the car, during most circumstances, have a shorter stop distance. To create a physics material, follow these steps. Go to the Assets section, right-click, and hover over Create. Click on Physics Material. And for improved organization of your project, I also recommend creating a folder to store these materials. Add the physics materials to the game objects, but do not forget to add a rigid body to the object you want to apply physics to. In my case, the sphere was the appropriate object. And do not forget to add mass to make physics more realistic. To calculate the mass, we first need to know the density of the material, and then its volume. And after doing some rough estimations, I got the mass to 4084 kilograms. The formula for calculating the force required to move the ball is: I've set the static friction and the dynamic friction to the same to make things simpler. There is, however, a problem with this approach, since Unity's add force method takes in a force and then multiplies it with the mass of the object, giving us a much larger force than the one in the variable force. To solve this, use this formula instead for the force variable. When two physics materials interact with each other, the friction is determined based on the friction combined settings of the materials involved. Here's an example to illustrate this. In the project, there are two physics materials applied to the game objects in the scene: brass PM and cast iron PM. Cast iron PM has its friction combined set to maximum. Brass PM has its friction combined set to average. According to the priority rules, the material with the maximum setting, cast iron PM, will govern the friction calculation. However, the friction value used will be the maximum friction value of the two materials. In this case, the maximum friction value belongs to brass PM, which is 0.6. Therefore, the combined friction affecting the object will be 0.6.